Welcome back to Science Unpacked. Today, we're diving into a fascinating paper by Dr. Pradeep Kumar about radiative heat transfer.
Oh, that sounds intriguing. Radiative heat transfer, like the warmth from a fire? Is that what we're talking about?
Exactly. It's all about how heat moves through electromagnetic waves. Think of a bonfire, or even the sun's warmth on your skin.
So, this paper looks at how that works in bigger, more complex systems. What are some examples?
Absolutely. It's crucial for engineering. We're talking about things like rocket base plate heating, protecting firefighters, and even combustion chambers.
Wow, from a campfire to a rocket. That's quite a range. So, why is understanding this heat transfer so important, though? Uh,
Well, it significantly influences temperature distribution and chemical reactions. In many systems, radiation contributes over 50% of the total heat transfer.
50%? That's huge. So, if you don't model it correctly, your designs could be way off, right?
Precisely. The paper looks at a can combustor as a primary example. It's like the engine of a jet or a power plant.
A can combustor. Okay. So they're trying to figure out how heat radiates inside this intense environment.
Yes, and they compare different radiation models, like Planck mean, WSGG, and SLW models, to see which one works best.
Different models for the same phenomenon? That's interesting. Do they give very different results then?
They do. The paper shows variations in temperature profiles and heat fluxes depending on the model used. It's quite significant.
So, choosing the right model is critical for predicting how hot parts of the combustor get and how much heat escapes.
Exactly. They even looked at the heat transfer rates at different sections, like the primary inlet, secondary inlet, and the walls.
And what did they find about those heat transfer rates? Was radiation a big player there too?
Definitely. The radiative component was substantial, especially at the outlet and on the walls. It can't be ignored.
That makes sense. If you're designing something that gets super hot, you need to know where all that heat is going. Fair enough.
Then they shift to another critical application, rocket base plate heating. This is where the exhaust plumes hit the rocket's base.
Oh, that sounds incredibly intense. Like a giant blowtorch pointed at the rocket itself. How do they study that?
They used numerical investigations to understand the thermal load. They simulated temperature contours at different altitudes, from sea level to high altitude.
So the temperature distribution of the base plate changes as the rocket climbs? That's a lot to consider for design.
Yes, the paper highlights how radiation governs this thermal loading. It's vital for ensuring the structural integrity of the rocket.
So, whether it's a combustor or a rocket, accurate radiation modeling is key to preventing failures and improving efficiency.
Precisely. The summary emphasizes that accurate radiation modeling is essential for designing efficient thermal systems across the board.
It's amazing how something we experience daily, like the warmth from a fire, becomes such a complex and critical engineering challenge.
Right? It really shows the importance of fundamental physics in advanced technological applications. Dr. Kumar's work is very insightful.
Absolutely. It makes you appreciate the science behind everything, from a cozy bonfire to a rocket soaring into space.
Indeed. And that's all for this episode of Science Unpacked. Join us next time for more scientific discoveries.
Thanks for tuning in, everyone. This paper truly underscores how crucial heat transfer is in our modern world.